Hello, everybody. So this is our second lesson for Tuesday, August 18th. So in Edmodo, you are going to scroll until you find 818 map projections. Again, we have our link for the reading. We have our map projections practice. Make sure you're doing the questions on this document. So we're going to get right to the reading. Okay, so a map projection is actually a way to show our round Earth on a flat sheet of paper. Okay? So there are different types of projections, and each is going to use a different way to change our three-dimensional Earth into a two-dimensional drawing. So the map maker is going to sort of slice the sphere of our Earth in some way and unfold it to make a flat map. So this would be like if you flattened out an orange peel. So an orange peel, you know, is the shape of a sphere. Actually, it goes around the orange, which is the shape of a sphere. But if you were to take off the orange peel very carefully and flatten it out, that is what it would be like to make a map projection. So the map maker can look at the sphere from a certain point and then change it into a view on flat paper. And there are a few different types of these, and they all have their own pros and cons, and they all have what they are best used for as far as location. So our first is the Mercator Projection. Okay, so this is if you wrap the Earth in a cylinder, and you use the cylinder where it touches the equator as your reference point. Okay? The image that is going to be projected onto the paper is the Mercator projection. So this isn't going to be as reliable farther away from the equator. It is going to be reliable closer to the equator. So when it's within 15 degrees north or south of the equator is when it is going to be the most accurate. So any land masses or countries that fall outside that 15 degree zone are going to get stretched out of shape. Okay, they're not going to be accurate as far as shape or size. Next, we have a conic projection. So this is called a conic projection because it's like you're taking a cone and wrapping it around the Earth. Okay? So conic projections work best at the pole. Okay? A gnomonic projection so this is going to be where you want us to map out a specific point on Earth. Okay, this is so this is how they map the poles, like at the specific point, because so let's go back a little bit. It's not so regions closer to the poles are going to be more accurate in a conic projection. So in a nomonic projection, it's going to be the most accurate for whichever specific spot you are trying to map out. They use this typically for the poles, to map out the poles, because otherwise the whole shape and size of the poles get distorted. Okay, now we're getting to a little more modern of a map projection. So in 1963, Arthur Robinson made a map with more accurate sizes and shapes of land areas. And the reason it was more accurate is because he took a mathematical approach. He used mathematical formulas that could directly translate into coordinates on the map. So took mathematical formulas and um, used them to put coordinates on the map. So the places on the map. So this projection, so 45 degrees north, 45 degrees south. So distances along the equator and the lines parallel to it, which are the latitude, are going to be true. Okay? The scales of each line of latitude are going to be different. This is probably the most accurate of all of the projections that I have presented today. So make sure you answer your questions and turn them into me.